So the final result tangent will be limit of f1 plus h minus f1 over h when h approach to 0. This will give us 2. We conclude the slope of the tangent line to the graph of y is equal x squared plus 2 at the point 1, 3 is given by 2. So here we have another example, which is example number 4 from your textbook. Find the slope of the tangent line to the graph of fx is equal root x minus 1 at x is equal 5. So again here we have a function. We ask to find the slope of the tangent line at the point x is equal 5. So again here we have f of x is equal root of x minus 1, x is equal 5. That's mean here our a is equal 5. So to find the slope we will write the rule tangent is equal limit of f a plus h, that's mean 5 plus h minus fa, which is f5 divided by h. We take the limit when h approach to 0. So this will give us limit f5 plus h, that's mean we go to the function f. We replace any x by 5 plus h. So this will be root. So x will be 5 plus h. Then we have minus 1, then minus f5. So we go to the function, we replace any x by 5. It will be 5 minus 1 divided by h when h approach to 0. So this will give us root of 5 plus h minus 1. So 5 minus 1 will be 4. So it will be limit of root 4 plus h minus root of 5 minus 1, so it will be root of 4 minus 1 is root of 4, sorry. So root of 4 will be 2, so here we have minus 2 divided by h when h approach to 0. So here if you use the direct substitution, you will get root of 4 plus 0, which is 2, 2 minus 2, 0 over 0, which is 0 over 0. So multiplied by the conjugate, root of 4 plus h. So here we will have root of 4 plus h plus 2 divided by root of 4 plus h, then plus 2. So after multiplied by the conjugate, then we have root of 4 plus h minus 2 multiplied by root of 4 plus h plus 2. So this will give us limit of, this root will cancel with this root, so we left with 4 plus h. Then we have minus 2 multiplied by 2, so it will be minus 4 divided by, here we have h multiplied by root of 4 plus h plus 2. We take the limit when h approach to 0. So since here we have 4 minus 4, so this will give us 0. So this will be equal to limit of h over h multiplied by root of 4 plus h plus 2. But here we say from the numerator we have h, for the denominator we have h, so we will cancel these 2h and we just left with limit of 1 over root of h plus 2. So this will give us limit of 1 over square root of 4 plus h plus 2 when h approach to 0. So now direct substitution, we left with 1 over square root of 4 plus 0 plus 2, which will give us 1 over 2 plus 2, which is 1 over 4. So the tangent is equal 1 over 4. So as we have seen that the tangent is given by limit of f5 plus h minus f5 over h when h approach to 0. This will give us 1 over 4. We conclude that the slope of the tangent line to the graph of fx is equal root x minus 1 at the point 5, 2 is given by 1 over 4. So note here, for any linear function given by y is equal mx plus b, the tangent line to its graph coincides with the line itself, not unexpectedly. Then the slope of the tangent line for any number x is equal a is given by m tangent is equal limit of fa plus h minus f of a over h when h approach to 0. Your function f is mx plus b, so you replace x by a plus h. This will be m multiplied by a plus h plus b minus f of a, you will replace x by a, so it will be ma plus b divided by h. Now here we have m multiplied by a plus h, so it will be ma mh. And we have here ma, so this ma will cancel with this ma. Then we have mh plus p minus p. So this p will cancel with this p because this one is negative. So we left from the numerator mh, from the denominator with h. We'll cancel h with h, so the limit of m when h approach to 0 it will be m. يعني هنا لو كانت عندنا معادلة خطية اللي هي معطينا إياها بال y is equal mx plus b، نريد نجيب سلوب للتانجنت لاين، على طول بيكون اللي هو معامل الx، بحيث إنه لو كانت بهذا الشكل y is equal mx plus b، إذا slope of the tangent line will be equal m. وهنا عندنا اللي هو proof. طبعا هنا في البروف أول شي بنجيب fa plus h، نروح عند المعادلة x plus b نبدل كل x ب a plus h، m multiplied by a plus h plus b minus f of a، نروح عند المعادلة نبدل كل x ب a، بيطلع لنا ma plus b over h. الحين هنا عندي m multiplied by a plus h، so ma will cancel with this one minus ma. هنا عندنا mh plus p، وهنا بقت من عندنا minus b، إذا ال b بتتكنسل مع minus b. So we left with mh over h. ال h بتتكنسل مع ال h، يبقى عندي limit of ال m لما ال h approach to 0. هنا ال m كأنها constant لأنه نجيب الليمت لل h، إذا الناتج is equal m. So up to here we have seen that the limit of fa plus h minus f of a over h when h approach to 0 is known by the m tangent, or the slope of the tangent line passing through the point a f of a. But are there cases where the tangent line may not exist? Let us see the following two examples. So the first case where we have a vertical tangent line, for example y is equal x power 1 over 3. At the point 0, we see that the tangent line at this point is the y-axis, where x is equal to 0. So here the tangent line is the y-axis, but we know that the slope of the y-axis does not exist because we divide by 0. So the first case where we have the vertical tangent line, so if you have vertical tangent line, that means the slope of the tangent line does not exist. And the case is y is equal x power 1 over 3 at the point 0 and 0, because this graph has a vertical tangent line at the point 0. يعني الفانكشن y is equal x 1 over 3 عند النقطة 0 0 نشوف إنه التانجنت لاين عبارة عن اللي هو ال y axis، ال x تساوي 0. We know that the slope is delta y over delta x. So the slope will be, the y will be difference, but the x will remain the same, it will be 0. So we divide by 0, that means the slope does not exist. So the first case where we don't have tangent line at the point 0, if we have the vertical tangent line. The second case here, if we have absolute value of x at the point, same point, which is 0 0. So which is this example show that the graph of fx is equal absolute value of x does not have a tangent at 0 0. So let us use the definition of the m tangent. Then we will apply the definition to the function absolute value of x, and we will see if this function has a tangent line or not. So we know that the m tangent is given by limit of fa plus h, where it is given here at the point 0. So here we'll replace a by 0. So f0 plus h minus f0 over h when h approach to 0. And our function is absolute value of x. So it will be 0 plus h, absolute value of 0 plus h, which is absolute value of h, minus f0, absolute value of 0, which is 0, divided by h, and we take the limit when h approach to 0. So this will give us limit absolute value of h over h when h approach to 0. Now since we have the absolute value, we need to take the limit from right and limit from left. So we know that absolute value of h, it is given by h and minus h. H if h greater than 0, minus h if h less than 0. So if we approach h from the if h approaches 0 from the right, we have the limit of absolute value of h over h, which is h cancel with h, we left with 1. So if h approaches to 0 from right, the limit is equal 1. Whereas the limit of absolute value of h over h when h approaches to 0 from left, we will take this 1, which is minus h over h. This will be minus 1. So we see that the limit from right is 1, the limit from left is minus 1. So the limit does not exist, and we conclude that this function doesn't have a tangent line. So the function is continuous. We see this one is continuous at 0. This I have seen from this graph. The function is continuous at 0, but the function doesn't have a tangent line at the point 0 and 0. And we see it doesn't have tangent line at the point 0, 0, because the limit from right when h approach to 0 does not equal to the limit when h approach to 0 from the limit of this definition, not the limit of the function. So we see that the slope is not equal. That means this function doesn't have a tangent line at the point 0, 0.